You ready? So you want to be a gold miner? I've been in this a while, going back to the days of post tags and hand-drawn map. It's an adventure. We all dream of making a big discovery. I don't have to do this. I get to do this. I'm sitting here today with John DeGrace, a retired geologist out of the Prince George Regional Office. John, can you tell us a bit about yourself?
Well, I grew up in Eastern Canada mostly, and came out to Prince George about 22 years ago because I was hired by the university there to work, and thought, well, you know, one more adventure before we finally retire might be kind of fun. So we come out thinking we'd be out for 5 years, and like a lot of people, 22 years later, we're still here.
You're still here?
Yeah.
Where did you get your degree?
Got it at Queen's, my first degree, and then that's in Kingston. And then from there I went to Memorial in Newfoundland and did my graduate work. And I thought I was going to have my whole career in Newfoundland. But the economy will kick people out of that province, and it kicked me out.
Yeah.
And so I moved from there to Ottawa, from there to Prince Edward Island, and then finally to here.
Into British Columbia. What was got you inspired into it in Newfoundland? What was the interest in Newfoundland?
Well, I never planned to be a geologist. I went to university. I was going to do mathematics of all things, and discovered that mathematics in university was way different from high school, and I didn't like it, and I couldn't do it. But I had this compulsory geology course, and I can remember sitting in the back of that class and just being fascinated. And I thought back to when I was 12 years old and the other kids were out playing baseball, and I was out behind the school with a hammer looking for fossils and hitting rocks. And it just never occurred to me until then you could get paid for this sort of thing.
So when did you begin working for the ministry?
Well, I came to BC actually to work up at the university as the university registrar of all things. And then they got a new president who decided he was going to let most of his middle managers go, because he came out of the U.S. and in those systems, when a new CEO comes in, they fire everybody and put their own team in. But it's really hard to find good people to work in northern BC. And at the time, I found out that the regional geologist in Prince George was leaving, and they were trying to find somebody new. And so I just happened to contact them at that time and say, look, would you be interested? And so you're darn right I was interested, and went down to be interviewed in Vancouver, and ended up being hired and coming up here.
What year was that?
That was 2007. But I wasn't a regional geologist forever after.
Yeah.
After a couple of years at the university, the new registrar had not worked out very well, so they offered me a raise and hired me back. And I was there for another couple of years, found that it really wasn't my thing anymore, so I got back into geology. Started out as a consultant, and then got back into the ministry. So it's been a bit tortuous in Prince George, but I've enjoyed it. What do you want?
So you moved into BC. You took up the job as the regional geologist out of Prince George.
Yep.
And this is where you settled and raised your family. And
Well, my family were already more or less adults. They were already in their 20s. So, but yeah, this is where I settled. And it's the longest I've lived anywhere.
yeah. So I guess BC's got a lot of geology here.
Oh God, yes.
Yeah.
Yeah.
What did you find some of the more fascinating parts up in here? Like, what was
There was so much variety in BC. You've got a complete cross section of the Western Cordillera, the Rockies, and every part of the cross section is different. It's all interesting and fun.
Oh, the terrains.
Yeah.
Yes, I found them very interesting myself in that, like in the with the terrains, like the tertiary river systems. They would run east-west and they would drain north through these massive faults. And these terrains, like each one of them, they seem to have their own story.
Well, if you go back looking at BC, these terrains that we have in BC, they're mostly what are called accretionary. So the Western Cordillera, the Rockies, built by putting one piece after another onto the western side of the mountains.
Mm-hmm.
And so and those terrains came from different areas. And so every time you cross a terrain boundary into a new one, it's like you're like walking onto a different island.
Right.
Except each one of those islands now is packed on to the west side of the mountains.
Mm-hmm.
So that's why there's so much variety.
One of the things I've noticed on a number of, I've been working on building a sort of treasure map, as it were, of mineralization in British Columbia, and I've noticed that there's even, you look at like Gibraltar, and you look at Mount Polly, and they almost line up together.
Yeah, they do. The terrain that we're in this part of BC is called the Quesnel terrain,
Mm-hmm.
and it extends from way south right up through the middle of the province towards the northwest.
Right.
And Mount Polly and Gibraltar are two mines that are built in what are called porphyry deposits. And there's a whole string of them coming up through the Quesnel terrain, one after the other, 15, 20 kilometers apart. Some are mineralized, some aren't, but they're all interesting.
Mm-hmm. Have you been following the geoscience magnetic flights that they've been doing?
Geoscience BCs?
Yes.
Yeah, I've kept an eye on them for sure. That's been tremendously helpful to people prospecting up here. Well, Geoscience BC has done a number of surveys up here. The magnetic one is really interesting. They've done a gravity survey that's been really interesting. So there's all kinds of stuff going on. And any knowledgeable geologist or company will look at these and they'll see what appears to be anomalous regions. And those are the ones they'll home in on. So they've got a pretty high magnetic anomaly, that'll attract interest. Some of what they have here, some of the gravity anomalies are very low, like for example around Prince George, and that's going to attract people's interest.
Mm-hmm.
So yeah.
How do these magnetic anomalies, what makes them so interesting, these high magnetics?
Well, if you've got a high magnetic anomaly, it means you have a lot of highly magnetized minerals there. Now, they're not necessarily ore minerals, but they're indicators.
Right.
So if there's a lot of magnetite and ilmenite, two magnetic minerals that are present in the rocks, that's going to cause you to home in and see what else might be there.
Right. So some of these magnetics would be forming with gold and,
Yes.
and silver.
Yeah.
Right? Mm-hmm. What's the most interesting discovery you've made in all your years in BC here?
I just haven't actually made discoveries in BC.
Mm-hmm.
The most interesting discovery I ever made was, believe it or not, it was in oil and gas. I spent a summer working for a company in Calgary, and they had me working in the northwest part of the province, in an area where there were a lot of what are called pinnacle reefs at depth, and I was able to show a method for finding pinnacle reefs that had not been drilled yet. In other words, I was able to find a way for them to develop some targets that should contain oil, and it turned out they did.
Oh, really?
So that was good fun.
What year was that?
Oh, a long time ago. That was 1967, I think.
Yeah. Oh, back.
68. I tell a lie. But yeah, that's going way back.
That was
It was never my business to go out making discoveries. Like the early part of my career was all doing geological survey mapping. So you take quite a large area, and that always fascinated me because the rocks tell a story of the history of that area. And for me, that was the fascinating thing, was working out that story and then writing about it, not going out and prospecting and making physical discoveries.
So you're in essence doing a second generation of this. You're
Yeah.
doing the mapping and then as well.
And you don't have to go back that far. I've got up on my wall at home, I've got a 1905 map of northern BC. Now in those days, of course, there were no aircraft, There are no satellites, nothing. So these guys had to go out and they had to walk the terrain. They'd walk hundreds and hundreds of miles, and they would take readings. They'd find the location, the south location of end of Stewart Lake, the north end of Stewart Lake, for example, and they'd maybe sketch an awful lot in between. It was amazing how accurate they could be. You know, they were really something. And then what would happen is in the 1920s and 30s beginning, but getting really serious in the 1940s, people would come in and do the first geological maps and start filling things in. And they were surprisingly good too.
This is where you had a hand in later on.
Well, yeah. But for example, I spent a year working with a company exploring for coal in northern BC. And so I had to use a lot of the maps that were made in the 40s and 50s. And they were really helpful, surprisingly so. Now, as time went on, the maps got more and more detailed. But some of those early efforts were really good.
Well, there were, yes. Everything was done by hand. No GPS, no computers. And none of that stuff came up until almost basically my time.
Well, up until almost the 2000s, your way of looking from above at the ground and sketching with the geology was air photos. And they'd take line after line of vertical photos and then stitch those together and then take them on the ground and plot the geology on them.
So they were doing their own photogrammetrics, but using the airplanes to do it.
Exactly.
Wow.
And these guys were good.
Yeah.
But I used to go out in the field, when all we had was air photographs, and you would have this line of stereo pairs of air photographs. You'd put a plastic overlay on them, take them out in the field. You'd have to mark your exact location of every spot where you took measurements and notes and so on, and then come back and plot them all on paper. And we had to do all that by hand.
Wow, that's a lot of work.
Yeah.
A lot of meticulous work.
Yeah, it was kind of meticulous.
It takes a certain patience to do that sort of thing.
Yeah, but it was fun.
Yeah.
Because what we were doing, we were sometimes the first people in there working out the story that the rocks were telling you. And that was just fascinating. So we'd be if I was working up in northern Newfoundland, you'd be able to spot the fact that you had a horizontal compression making one fold, and that fold was compressed to make vertical, crenulations. And we were counting up to 5 separate deformations in the rocks in some places. And so just unraveling all that folding and faulting was a tremendous challenge.
So, there's some publications. Have you have a hand in authoring?
Oh, yes.
Yes?
Yeah.
Do you have a few in mind that you'd like to share?
Well, a lot of what I did in Newfoundland was on what's called the Cape St. John Peninsula, which is quite a large body of land sticking out into the North Atlantic. And so I had a fairly serious hand in authoring one of the major geological reports that came out on that area. And that was really good fun. You have to enjoy it, because a lot of what we were doing, we're going way east, Newfoundland, you've got almost 100% rock exposure along the coast. And so we go out on the ocean in small wooden boats, and you'd spend your summer nosing into the shoreline, which was often rocky cliffs, in every location you could. And then you'd get out of the boat and you'd walk along as far as you could, doing your geological work, and then finally you get to the point where you couldn't go anymore, and you'd wave to your boatman. He'd come over and pick you up and move you on. So we did a lot of work like that.
You must have, from what I understand, Newfoundland and Labrador have some of the most complete fossil records of the planet. Some of the best.
I wouldn't go that far. There are better fossil records around. Newfoundland has its charms that way. But what's interesting about Newfoundland is one of the few places where you can get a complete cross-section of a mountain belt. Okay, because it's all exposed on the shore. It's wave-washed, and so you can see everything. If you come to a place like BC and you walk across the Cordillera, there's an awful lot where you can't see anything because it's covered by overburden.
Right.
you know, so it's not as complete a record.
Right, because the glaciation's pushed and buried in all these different
Exactly,
valleys and all these
exactly.
clues.
Newfoundland is very well exposed, and you can see an awful lot.
Mhm. That must have been the allure, I guess, with BC, is there's so much unknown here, eh?
Oh yeah,
Yeah.
oh yeah. BC is they're still finding basic information about the geology of this province today. So yeah, still people are still finding good things.
They're making discoveries every day. How much, I've heard the expression as far as BC, as far as how much of its resources have been mined. People have said about 2%. Do you concur with that, or?
Yeah, that's about it.
Yeah.
There's maybe less than 5% of BC has been disturbed by mining of any sort. At least less than 5% has ever had a mining lease on it. Now, within those mining leases, the actual areas mined were very small.
Mm-hmm.
So the other interesting thing about BC is that there are roughly 14,000 mineral occurrences in the province, but very few mines, because most of those are just of interest to prospectors. So the distance between a prospect and a mine is thousands of places looked at, many thousands of places, before you actually make a mine. They say the chances of a mineral occurrence becoming a mine are less than 1 in 10,000.
Yeah.
You know?
There's quite a bit of.
So there's an awful lot of looking. And if you look at the way people are exploring for mines now, the vast majority of people that are out there are looking at mineral occurrences that we already know about, going back over the same ground over and over again, and not doing that much of what you would call grassroots exploration, looking at ground that nobody has looked at.
Mm-hmm.
Yeah, so if you look at the money spent every year on mineral exploration, I'd say less than 10% of it goes to grassroots exploration.
Mm-hmm.
Well, we were out today looking at places we could take people on the course to for a field trip.
Yeah.
And one of the things I've always known is that it's nice when you can scout some things out. That's what we were doing today. But the fact of the matter is you can take a person on an introductory course like that out just about anywhere and find things to tell them that they wouldn't have known. So it's always educational for them.
Mm-hmm.
And what we were doing this morning, we were out at an old limestone quarry actually. But in that quarry, sedimentary beds are always laid down horizontally at first. But if you're in a mountain belt like this, that's been squeezed and deformed, the beds are always at an angle.
Okay.
So if you're describing the geology of an area that's been structurally deformed like that, it's been faulted and folded and so on, you have to be able to measure the orientation of the beds, the sense of direction on the faults, all these sorts of things. And so you need to take people out in the field and say, all right, this is how you measure what's called the attitude of a sedimentary bed. The slightly more technical terms are strike and dip. Mm-hmm. And so when I'm teaching, I always say, this is going to be on the exam, memorize it. This is the definition of a strike and this is the definition of a dip. And of course, it comes time for the exam, they never remember a thing. But if they're going to get out and actually do the work, you have to. And it's the same thing with your basic rock types. There are probably, if you want to look at basic igneous rock types, and igneous rock is one that crystallized from a melt, there may be 20 different types. That's not very many, but you have to know the definitions of those cold. Because if you're going out in the field, it's not enough to say, it looks like a granite. It might be, but it could be 10 other different types of rock. And so for that, you have to be able to look at the rock, identify the minerals that compose it, and from that, name the rock and name it accurately. So you're always trying to do that. You're always trying to look up close and see what you're really looking at,
Right.
and define it.
Mm-hmm. So you're looking to teach the students this on the new course here?
Well, there's only so much you can do in a short course,
Yeah.
but I'll teach them everything I can. And what I'm doing is leaving them all with a reference book that they can take, and they can use that. They can go back to that again and again and it'll be a basic help.
What book is it that?
Well, the book is it's sort of a standard reference. It's made for people that are not geologists but are really interested in the industry. It's entitled Mining Explained, and it's put out by Northern Miner Press.
Okay.
And so we want to get copies of that into people's hands. I found it one of the most useful basic references for people.
Okay.
And some you have around for ages. Like I took my first course in mineralogy, that is learning to identify and understand minerals. I took in 1966, believe it or not. And I've still got that book, and it's still my best reference. Because the minerals don't change that much. If you find a really solid reference, you keep it. Other areas of the science are constantly changing. And so, like the whole science of what's called tectonics, mountain building, is still being developed. People are still making discoveries and refining the way things work. So for that, you want a more recent reference.
Right.
I've seen old geological reports from the 1940s, and they can still be helpful to look at because the geologists describe very accurately what they saw. But the interpretations they put on it in today's way of thinking things are just wildly out of whack.
Yeah.
Because people have learned so much about the way things work, about the way mountains develop, about the way sedimentary rocks are laid down, about the history of life through the fossil record. The way people look at things now is nothing the way it was looked at 50 or 100 years ago, because people have kept on developing their thoughts about the science.
Yeah, they didn't have the resources that we have today to be able to, but they also.
No, and they didn't have the, one of the things today is that you have a lot of different sets of eyes that have looked at things with a lot of different backgrounds. They say that if you do a geological map, for example, of an area, you do it once, and that's not going to last you forever. Most people that run geological surveys find that you have to go back about every 10 years and then map it again, because ideas have changed so much that you're going to be looking for different things when you go at an area again. So when you're going into an area, yes, you want to know about the history of who did what, but you always want to find the most recent good map and really get into that.
What's your thoughts for BC and its future?
BC has a great future. This is still sort of on the cutting edge of geology and exploration. There is so much variety here. It's just plain fun to work in. So I would. Anybody who wants to come here, I'd say come. You won't be sorry. Oddly enough, the other end of the country that I really like is Newfoundland and Labrador. People are still making major discoveries there. But almost anywhere, there's still things to be found.
There's some discoveries that come to mind that you'd like to share with us?
Well, see, in British Columbia, just locally here, Mount Milligan is almost a new deposit model. If you look at the guys that discovered it, they said, this is completely new. We've never seen anything quite like this. And yet here it is, a major mine right in the middle of BC, just about exactly in the center of BC. So I'd say that's certainly one. North of the old Kemess mine, there's one near the Lawyers Prospect that looks like it's going to be a major one. So that's two in BC. That's precious metals north of Kemess. If you want to go to Ontario, the Hemlo gold mine was interesting because it was discovered when the Department of Highways wanted to widen the highway up there, so they had to put in a new rock cut. Okay. And as soon as anybody goes through with a rock cut, you can be sure there's going to be geologists come along. And they found the discovery outcrop for that mine, which has been a major gold mine, right where they opened the road.
Where they're going to put the road.
Yeah. So that's kind of a neat one. There's a major nickel deposit in Labrador that I think is well worth looking at. And there have been a number of gold discoveries on the island of Newfoundland that are worth looking at. So there's stuff all over the place being found.
If you're looking for gold and silver and those types of metals, you're going to miss all this other stuff that we're looking for now.
One of the One of my favorite stories when I was working down around Barkerville and so on was had to do with an area where a mining company was looking for a low-grade gold deposit in the bedrock. And there was also a placer miner up there who was mining the creeks there and was working on an old creek bed, and so he needed water, wash water.
Yeah.
So there were a whole lot of ditches built along the roads there, and the placer miner wanted to back them up and make little reservoirs for his project, and the miner wanted the things to run free so he could have access to water for anything he wanted, for a drill program or whatever.
Mm-hmm.
The two of them ended up arguing endlessly about who owned the roadsides for these water courses. And so they sent a claims adjuster out from Victoria who ended up standing on the road with these two guys, the placer miner and the bedrock explorationist, arguing about who owned these things. And finally, the claims adjuster said, okay, who put these roadways in originally? And there was a brief pause, and well, it was the Chinese in the 1860s. So I remember he said, okay, I want you two to go down to the coffee shop there, have a coffee, work it out, and tell me what you worked out, because I'm not going to have any more to do with this. And so the two of them went down, had a cup of coffee, worked it out, and they came back, and it was fine.
They sorted it out.
Yeah.
Nice. Well, they're always going out like gold, silver, platinum, but I mean, you look at where we're evolving now. Like we've, the government wants to take BC electric, and the world's going electric. Well, they're looking at everything from zinc to nickel to all these lithium to all these deposits of minerals that we never really looked at before.
No.
And
No, if you are really serious into building electronic products, whether it's cars or computers or anything else, you need some fairly exotic materials. And so light and heavy rare earth elements are important. We've got 3 or 4 good deposits in BC. East of Bear Lake, there's what's called the Wichita deposit, which is light rare earths. And they're very active work going on there. And that, if it were ever developed, and it may be, it would be one of the top 15 or 20 rare earth deposits in the world in terms of size. So there's a lot out there, and they're not necessarily very big, But at the same time, it's thought that copper in the mineral industry is going to be like the next oil, because it's needed for everything. It's one of the very best conductors. It's needed for all electronics, for power projects, for what have you, because power needs in the world generally are going to go way up. If you want to build electric vehicles, you're going to have to power them. And so that's going to call for huge amounts of generating capacity and copper.
copper wiring for that.
Yeah.
I've heard we don't have the infrastructure to really support the electric car.
Well, we thought we did. I mean, most of BC's power is hydroelectric. And that's perfect for running vehicles because you're not burning oil or natural gas to generate electricity.
Yeah.
So it's really nice if you can use solar, wind, hydro, whatever else to generate your power. We've got all of those in BC. So we stand to be kind of an electric energy powerhouse for all of Canada. And so that's a good thing. I don't want to be too positive about this, but it's possible that the future of energy in the world is not in oil or natural gas, it's in electricity. Electricity, when you can't get it from hydro or anything else, or wind or solar, is going to come from hydrogen.
Yeah.
And hydrogen, yes, it can be found underground and extracted the same as you would natural gas, but it's not that common. Most hydrogen is going to come from splitting water, because water is a compound of hydrogen and oxygen. And some really good ways to split water. Well, hydroelectricity is one, because it's zero emissions. To transition to that, you can take natural gas, and natural gas is methane. The chemical formula is CH4. So you can extract hydrogen from the methane. Now you're leaving behind carbon. Carbon can be pumped into the ground and stored that way. And you can take hydrogen, pure hydrogen, and you can dilute natural gas with it by up to 50%. That's what goes through your pipeline into your home. So you can take that natural gas and you can make it 50% pure hydrogen. You don't have to retrofit anything. You can just use it.
You just use it, yeah.
So there are lots of ways you can ease into a hydrogen economy. Years and years ago, I used to work for the Library of Parliament. And Parliament then created what they call the Alternative Energy and Oil Substitution. That's what it was, pardon me. Anyway, so we worked for a couple of years. I was a researcher on that team along with the members of Parliament. And the committee came to the view that the way Canada should be looking is in what's called an energy economy based on hydrogen and electricity, not on oil and natural gas, hydrogen and electricity. And we suggested ways you could transition to that. And it received a whole lot of press. This was back in the around 1980, whole lot of press. And we made page 1 of the Globe and Mail until some guy in Turkey tried to assassinate the Pope.
Oh, yeah.
All of a sudden we're back on page 10.
It just got moved pretty quick there.
But I still have people expressing interest in that report because it still remains pretty prescient.
Yeah. We also conclude the interview with John DeGrace. Thank you for joining us.
Pleasure.